In the official archives, Princess Diana's ancestry was always described as purely English, until a 2025 DNA test uncovered a rare Iberian Mediterranean genetic signature hidden deep within her maternal line. This revelation challenged centuries of royal history, left medical experts re-evaluating her lifelong health struggles, and set historians scrambling to explain the silent gaps in the Spencer family's records. How did a secret this profound escape centuries of scrutiny, and what else remains buried in the bloodline of Britain's most famous princess? Subscribe now as we go back to the medieval voids that made this genetic mystery possible. In the parish registers and dowry books of late medieval England, the Spencer name stands out not just for its prominence, but for the silence that surrounds its maternal ancestry. Between 1380 and 1550, 3 consecutive generations of Spencer men, Sir John Spencer of Great Brington, Sir William Spencer of Althorpe, and Sir John Spencer of Wormleighton, appear in official records without any documented wives. No marriage contracts, no dowry settlements, and no parish entries name the women who bore the family's heirs. Historians examining the Northamptonshire and Warwickshire archives find property transfers and wills that mention sons and daughters, yet the mothers remain unnamed. Dr. Elizabeth Hart, an archivist at the Northamptonshire Record Office, notes that even for a family of the Spencers' stature, this absence is striking. In late medieval England, unless a marriage brought significant land or political alliance, the wife's identity often went unrecorded. Dr. James Willoughby of Cambridge adds that such omissions were common, but the consecutive gaps in the Spencer maternal line are unusually persistent. This archival silence is amplified by the loss or destruction of many dowry books and the late standardization of parish registers, which did not routinely include maternal names until the mid-16th century. Some experts, like Dr. Sarah Bendel of the Society of Genealogists, argue that these missing records could mask marriages to women from abroad, especially during periods of increased Anglo-Iberian contact. The result is a centuries-long gap that leaves historians reliant on indirect evidence, and that sets the stage for genetic research to fill in what the archives cannot. In 1386, the Treaty of Windsor forged a lasting alliance between England and Portugal, opening new diplomatic and commercial channels across the Western seaways. Marriage contracts soon followed, linking English nobility with Iberian houses in ways that bypassed the usual scrutiny of English parish records. Aristocratic brides, often unnamed in English documents, travelled north aboard merchant convoys and royal envoys, their arrivals recorded only in the ledgers of dowry brokers and the correspondence of diplomats. Shipping lanes from Lisbon to Bristol and Plymouth became well established, supporting a steady flow of goods, envoys, and, on occasion, noblewomen destined for English households. Historians point to the surviving marriage treaties between the Plantagenets and the Braganza and Trastamara dynasties as evidence that these roots were not theoretical. The Treaty of Windsor allowed Portuguese and Spanish vessels to dock routinely in English ports, facilitating the kind of discreet, politically motivated unions that might escape formal English documentation. Dr. Ana Ferreira, a specialist in medieval Iberian migration, notes that the period's diplomatic correspondence often references unnamed daughters or sisters sent abroad for marriage, their identities preserved only in the archives of their home countries. This context makes the possibility of an undocumented Iberian bride in the Spencer maternal line entirely plausible and concrete. With established maritime routes and a political climate that encouraged cross-border alliances, the mechanisms for maternal migration were firmly in place. These treaty routes and diplomatic exchanges now offer a historical pathway for the introduction of a rare Mediterranean mitochondrial lineage, setting the stage for genetic evidence to test what the records left unsaid. Late in 2024, a team at University College London began analysing mitochondrial DNA from Spencer family descendants using next-generation sequencing platforms. Each sample underwent ultra-high resolution mapping, allowing researchers to read every base pair in the mitochondrial genome with coverage depths exceeding 1,000 times. This level of detail was impossible just a few years earlier. The bioinformatics dashboard tracked the data in real time as algorithms sorted the sequences into known haplogroups. Most Spencer-linked samples clustered within expected Northern European lineages. But one set of results triggered a flag. The maternal haplogroup did not fit any known British aristocratic pattern. Instead, it matched a rare variant most commonly found in the Iberian Peninsula and parts of the Western Mediterranean. The lead bioinformatician, reviewing the clustering output, noted an outlier that persisted across multiple runs. Initial suspicion fell on possible contamination or a software misalignment. To rule out error, the team reprocessed the raw data and compared it against over 250,000 public mitochondrial sequences. The anomaly held firm. The outlier sample repeatedly grouped with haplogroup H1J, a lineage virtually absent from British genealogical records, but well documented in Iberian population studies. Internal logs timestamped the detection to December 18, 2024. The finding was unexpected and prompted immediate discussion among the team. While the technical protocols confirmed the data's integrity, the result challenged assumptions built on centuries of family records. The question now is whether this rare signature could be replicated in other Spencer-linked maternal samples, and if so, what it might reveal about the family's undocumented past. Confirmation of the Iberian Mediterranean mitochondrial haplogroup did not rest on a single laboratory's findings. Early in 2025, the research consortium initiated a rigorous multi-laboratory validation protocol, requesting independent resequencing of the original Spencer-linked samples at 2 additional accredited facilities. Each lab received freshly collected, bar-coded samples from verified female line descendants, processed under strict chain of custody guidelines. The laboratories operated blind to the initial results, using separate sequencing platforms and variant calling pipelines. Within weeks, all 3 sites reported concordant results. The rare H1J haplogroup appeared in every Spencer maternal sample analyzed, with no evidence of contamination or sample mix-up. Internal audit logs documented negative controls, reagent tracking, and full traceability from collection to analysis, satisfying the highest standards of genetic research. The findings were time-stamped and cross-checked against the Pan-European mitochondrial database, confirming the rarity of H1J in British lineages and its established presence in Iberian populations. A brief from the second site laboratory, delivered in February 2025, outlined the identical haplogroup assignment and variant profile, reinforcing the initial discovery. A third-party quality control review further scrutinized extraction methods and sequencing depth, reporting no anomalies. By March 2025, the research consortium reached consensus that the Spencer maternal line harbored a mitochondrial signature that could not be explained by known British genealogies. This level of replication and transparency left little room for doubt, setting a new benchmark for the validation of historical genetic findings. Subscribe for more investigative royal history content. A mitochondrial variant identified in the Spencer maternal line has drawn the attention of clinical immunologists because of its association with autoimmune risk. Dr. Amelia Morell, a consultant at King's College, explains that this variant, rare in Britain yet well documented in Iberian populations, can subtly alter immune regulation. Archived physician notes from the 1990s detail Diana's struggles with chronic fatigue, recurring joint inflammation, and periods of unexplained immune disturbance. While these symptoms never fit a textbook diagnosis, the genetic marker now offers a plausible explanation for the pattern seen in Diana and some Spencer relatives. Dr. Morell cautions that the presence of this variant is consistent with, but not proof of, the health issues described in Diana's medical records. Association studies suggest a higher risk of autoimmune conditions among carriers, yet the link remains statistical, not definitive. The findings invite careful interpretation, balancing scientific insight with the complexity of lived experience. Subscribe for more investigative royal history content. A confidential memorandum circulated between Buckingham Palace and the College of Arms in May 2025 outlined the official stance on the mitochondrial discovery. The Palace Communications Advisor recommended a policy of factual transparency, instructing staff to avoid speculation and to refer any press inquiries to the published scientific record. The College of Arms spokesperson acknowledged the need for a thorough review of genealogical protocols, but emphasized that no amendments to the Spencer family lineage would proceed without full peer-reviewed validation. Legal counsel specializing in data protection confirmed that all genetic analyses complied with GDPR and UK consent requirements, with explicit permission obtained from living Spencer descendants for each new sample. The memo stressed the importance of safeguarding personal data, citing anonymization procedures and the exclusion of living direct heirs from any public reporting. As the findings await formal publication, both royal and genealogical institutions have committed to independent academic scrutiny, underscoring a cautious, process-driven response to the genetic revelations. As genetic technology reshapes what we know about history, even the most sacred family trees face new scrutiny. In an era where DNA outpaces legend, royal bloodlines become stories still being written, gene by gene. The past isn't fixed. It is waiting to be discovered. Subscribe for more untold royal truths.